A square loop with 2-meter sides is perpendicular to a uniform magnetic field with half the area of the loop in the field as shown in the figure. The loop contains a 20-volt battery with negligible internal resistance. If the magnitude of the field varies with time according to B equals to 0.042 minus 0.87 t with B in Tesla and t in seconds, the net EMF of the circuit is. So here we can see that the magnetic field is coming out of the page, right? And if you plot a graph between this magnetic field and time t, we can see that it is having a negative slope, right? That means the magnetic field is basically decreasing. If magnetic field is decreasing, what the induced current will try to do? It will try to basically whatever the oppose the change. What is the change happening here? The flux is reducing when the magnetic field is out of the page. So the induced current will try to oppose it by creating magnetic field out of the page. So the induced current should flow like this. I induced. So I can say that this battery 20 volt as well as the EMF induced, both are in series. So let's find out what is the induced EMF. Induced EMF is d phi by dt with the modulus, right? So here the square loop is having 2 meters as side length and only half of the area is having the magnetic field. So it is half into 2 square into dB by dt. We are interested only in the magnitude, which is 2 times of dB by dt, which is 0 minus 0.87. Since we are interested only in magnitude, it is 2 into 0.87. That would be 1.74 volts is the induced EMF, right? So the total EMF is 20 and E induced, both are in series. So total is 20 plus 1.74, which is 21.74 volts is the total EMF that is induced within this loop. That would be our option C.